radians. What the heck? So I keep talking about radians, and then you can do angles in radians or angles in degrees. So we know at least radians are going to be angles. Okay, so let's just write that down. They're angles. Okay, big deal. Let's get a better definition, okay? So what I like to do before I even start is draw you a picture so you get the idea of why radians are important, okay? So in geometry, let's see here. Oh yeah, I want this one. Okay, you don't have to write this down. I just want you to watch, okay? In geometry, we talked about, hopefully, just don't write this down, just watch. So we talked about things like if this is 60 degrees in geometry, then the arc was 60 degrees. And then if, I know you're going to get the heck, you're going to understand this, okay? And then, I like to start this way. If that's 60 degrees, then this arc is 60 degrees, okay? And then, do another, okay? And then, same thing here. Okay, if that's 60 degrees, then that's also 60 degrees, and then, right, if this is 60 degrees, and this is 60 degrees. Okay, so I'm hoping you're going to see something that's weird about this. I'm hoping you're going to say, wait a minute, Mr. Davies, how can all of these arcs be the same thing? They can't. I mean, it's just a rotation. When we did in geometry about a 60 degrees, we're talking about a 60 degree rotation, but the arc length isn't 60, right? So the angle and the arc length are equal, and the angle and the arc length are equal, but then there's no way that is equal to that, which is equal to that, which is equal to, correct? And that's where radians come in. So radians are where so a radian is an angle, measure. Okay, write that down. Radian is an angle. I'm going to highlight angle because it's an angle. Okay, radians are where an angle measure where the arc length is equal to the angle. Okay. Hi, Abby. I got it right there from front of you, huh? How do you like that? All right, we got to do notes right away because we're out of here early, okay? So then, if we take a look at a drawing here, so if we have a circle and the radius of the circle, the radius is equal to 1, okay? So I got 1, 1. And then this arc length, so if I were to measure this is 1, this one, and if I could measure the arc length, almost take it off the circle, this much of it, and stretch it out and measure it, right? It would also be 1. So that is 1 radius. So this angle is defined as 1 radian if the radius is 1 and the arc length is 1, the angle is 1 radian, okay? So 1 radian is where the arc length and radius is also equal to 1. So then you have a connection between the angle and the arc length, okay? Now, we know a little bit about geometry, hopefully. We know that if you were to take a look at a circle, I'm going to draw a circle for you, right over here. And then we learned in geometry that the circumference of a circle is equal to 2 times the radius times pi. We know that from geometry, right? So the circumference of this circle is 2 pi. So that means that the rotation of our angle is also 2 pi, okay? Let's go right there, 90, okay? So that's 90 degrees, but then if we called it an angle theta in terms of radians, so theta is 90 degrees, but it's also going to be pi over 2 radians, okay? And we're going to talk more about this tomorrow, but I know, now think about this, we're smart, okay? If all the way around is 2 pi, because I told you, the circumference is 2 pi, halfway around the circle is pi, and then half of that at 90 is going to be pi half. So we have an angle, 90 degrees, and pi halves radians are the same angle. We have an angle of 180 degrees, and the same angle is going to be pi. These two angles are the same. They're both the same angles. One's in terms of degrees, and one's in terms of radius. So watch this on the calculator real quick, okay? I just want you guys to see. If I do, what's my mode, okay? My mode's in degree, okay? Good, okay? If I did cosine of 180 degrees, okay? I get an answer of -1, okay? Mode, radians. If I did cosine of pi, what do I get? Same answer. The two angles are the same angle. This is in terms of degrees. This is in terms of radians. They're the same angle. The reason why you do radians is because it connects the arc length to the angle. Okay, we're going to talk more and more about that, okay? Now, let's go back. Let's go back to a little bit of geometry. So this one says, draw a picture and give the angle in standard position. Well, okay, I can do that. Well, let me go ahead and guys have circles. If you don't have circles, let's see if we can draw a circle, okay? Just going to draw a circle. If you guys don't have draw a circle, you guys want to borrow my templates? I got more templates too. Anybody want to borrow more templates for nice circles? Doesn't matter. Anybody? Karen? No? They're kind of beat up. This one's going to beat up. You want a nice circle? Kaylin, you okay? All right. So let's see here. If I want to draw a picture of the angle in position, I know that 400 degrees is the same as 360 plus 40, right? Let's scroll that out, sorry. So to draw this angle, we'd go around 360 degrees and back to 40. That makes sense, doesn't it? It's like rolling the wheel 400 degrees. So you got to go all the way around and 40 more. And then if I wanted to do negative 100 degrees, well, let's see here. Go draw my circle. So if it's negative, it's just backwards, that's all. We're going to go backwards, okay? So we're going to take this and we're going to go backwards 100 degrees. So my rotation is going to go backwards 100 degrees. It could be negative 100 degrees. It could also be same position. It could also be same position at 260 degrees, right? So if I took a tire on my car, I rolled it 260 degrees this way, then think about this. You got a nail in your tire, doggone it. And I want to fix that nail. So I could either take my tire and rotate it 260 degrees toward me, or I can take my tire and rotate it back 100 degrees. Same position, right? Same position. I want to find the nail. I'm standing here. I can either rotate it this way, or I can rotate it that way, okay? Now, this 15 pi force, let's see. 4 goes into 15 3 times, right? So I got 3 and 3/4 pi, okay? Now, let's see how that's going to work. And we're going to talk more about this tomorrow, okay? This is going to be new to you, okay? So, if I went all the way around the circle, I just went 2 pi. See, 2 pi and 360 degrees are equivalent. in terms of radians. 2 pi and 360 degrees are equivalent. Okay, then I got to go, if I want to go 3 3/4, so then I'm going to go another pi. So I've got 2 pi plus a 1 pi. So I'm going to go another pi, puts me right here. Okay. And then I got to go 3/4 of a pi. Let's see. I'm going to have 1/4, 2/4, 3/4 puts me right there. And we're going to talk more about this tomorrow because it's going to be a little hard for you. That is 3 3/4 pi. Okay, watch. I'll let you see it again, okay? Wait till you're ready. Okay, when you're ready, I'll show it one more time so you guys can see it. Okay, here we go. You guys watching? So I want 3 3/4, which is the same as 2 pi plus 1 pi plus a 3/4 of a pi, okay? 2 pi is a full circle. So I want 3 3/4. So I'm going to go 2 pi, then another 1 pi, and then a 3/4. 1/4, 2/4, 3/4 puts me right there, okay? And again, this is going to seem really weird to you, but we're going to talk about this again more tomorrow, okay? All right, example 2. Am I going too fast? You guys want to think about this one for a little bit more? Ready? 3 3/4, 2 plus 1 makes 3 plus 3/4. So 2 pi is all the way around, then a pi is halfway, and then I need 3/4, which is, divide this into fourths. There's 1/4, 2/4, 3/4, okay? Now, example 2, find an angle both positive and negative that is it should say coterminal. I can't spell. Never have been able to spell. Coterminal is 60 degrees. So I'm going to draw a little picture. I like the circle. Circles always help me. Okay, there's about 60 degrees right there. So 60 degrees is a rotation this way, right? There's 60. Now, finding both positive and negative, that's coterminal. Okay, so now if I need another, so again, this is back to the, you wake up and you got a flat on your tire and you're bummed. So the tire has the nail in it right here. So if I want to fix it, I could rotate the tire all the way around 360. So so I could have a 360 plus a 60 makes a 420 degrees. I'm in the same spot. I'm in the same spot, right? Take the tire, it's right here, rotate another 360, 420. 420 and 60 degrees are in the same spot. Now I could also rotate it backwards, right? Okay, so if I take my 60 and rotate it backwards, I would take my 60 degrees minus 360 degrees, because I'm going to rotate it backwards, puts me at a negative 300 degrees. All three of these angles, as far as a rotation, puts me in the exact same position. Okay, you right with that? B. Let's take a look at B. Okay, I'm going to draw a picture. I like the picture. Pictures make it a little bit easier. Okay. Okay, 120 degrees. We're going to go backwards because of the negative. Okay, the negative means we're going to rotate backwards. So it's taking the tire. I'm going to rotate the tire backwards. So we're going to rotate back 90. 120 might be about there. Okay. I know I go about 90. 120 might be about there. So negative 120 degrees. So that means, like, again, I like to say the nail in the tire is there. So we could rotate this back around, right? So we can take my negative 120, going to add my 360 to it, right? Or put us at 240 degrees. Same position, but the 240 just is this angle here. There's my 240. Same position, right? If I want to rotate it backwards again, because it says we want both a positive and a negative, that's coterminal. So if I need another negative angle, I'll take my negative 120 degrees, and I'll spin it backwards a full 360. I'll spin it backwards one more time. Minus another 360. What's that? Negative 480 degrees would be the exact same. So all three of these angles put the nail in the same spot. Does that help? Okay. Now, homework. I'm only going to give you half of it today, and we're going to go ahead and look at the other half tomorrow, okay? Because